All right. Yeah. So this is basically what you will be using for your project, right? Now, people. Yeah. So this is what you'll be using for your project. Because your project, your group project, is a convolutional neural network. That's what you're creating for your group project. Now, remember, when we do research, there's two big pieces of your research, right? There's your literature review, which builds up an argument using previous studies, right? Isaac Newton said that by standing on the shoulders of others, we see further, right? By standing on the shoulders of others, we see further. So when you stand up on this desk, you see further. If you ever been to a cricket match and you see a dad, you might have seen some moms do. You see that dad hold up the son or daughter on their, you ever seen them hold their son or daughter on their shoulders? Anybody ever seen that? You never seen that? You have the 3-year-old kid. You can't see through the crowd. You can't see Sachin Tendulkar, right? So the dad takes up the daughter or the son, puts them on the shoulder, right? And so by doing that, the son or daughter can see further over the crowd, right? Same thing happens when we cite studies of previous work. That's why we start, that's why the project idea has 3 similar studies that you're going to build on. Yeah. Because you can, all right, now this idea applies mostly to regression. But the idea is that you can do anything with data. You can manipulate data and do anything with data. So by building on previous studies, you demonstrate that your study is theoretically sound. It's theoretically sound, right? So you're going to have this convolutional neural network that you're building, but you're also going to cite previous works, right? All right. Now, so as we said, it's basically manipulating this training, this data set that has 50,000 training images, 10,000 test images, right? Remember, you always have your train set and your test set. Your train set and your test set, right? Train set and your test set. All right. Now, let me ask these guys. I want to hear something. Can you folks in 114 hear me properly? Can the folks in 114 hear me properly? Barath Badula said yes. Okay, very cool. All right, very good, very good. All right, so remember, you always have train set and test set, right? Now, in some cases, you will have the train set, the validation set, and the test set. Remember, the model learns from the training set, right? The validation set helps you to see whether the model is overfitting while it's being trained, right? Right? Because remember, it will learn the patterns in the training set perfectly. In almost every model, you'll find that the training accuracy approaches 100% very easily, meaning that it learns the patterns within the training set perfectly, right? And so I can't tell you how important it is to understand this, right? So it's like, for example, we have the people in 217, we have the people in 114. If I get to know you folks in 217 perfectly, I might be able to tell some things about the people in 114, right? I can make a guess that most of them are from Telangana. But take, for example, suppose the people in 217 are mostly from the city, right? But suppose the people in 114 are mostly from the rural parts. They're mostly farmers. Then if I learn only from this training set in 217, then when I try to apply it to the people in 114, I'm going to get some things wrong, right? Because the model is overfit to the people in 217. Overfit means you know one set of data perfectly well, but you cannot apply the lessons learned to the next set of data, right? All right, very good. Cool. So you have the training set that the model will learn from. It will learn the patterns within the training set, right? You have the validation set, which it will test while it is learning, right? And the validation accuracy is going to be less because it's learning from one set and trying to apply it to another set, but it's going to be getting some things wrong, right? All right, very cool. And then the final test set is, you know, before you hand the model over to your users, you're going to train it on the test set and you're going to tell them, okay, this is the accuracy of the model. This is the accuracy you can expect. 1 in 10 or 1 in 20 or 1 in 50, hopefully more like 1 in 50, you may get it wrong, right? Which means you have a 98% accuracy. All right, so we'll load the libraries, right? Remember that Python doesn't keep all the code in the basic Python code set, right? You have these other libraries, and with open source, what it means is that people can, Python is what we call open source, right? So people can write code libraries for Python, right? Can write libraries or what they also call packages, yeah? So you actually have a bunch of different deep learning packages for deep learning libraries for Python, right? Tons of them. All right. You have the X train, Y train, X test, Y test. Remember, essentially, this is going to be a training set. The model will learn directly from this data. It's going to test or validate. In this case, you're going to see where it's actually validating on this test set, right? All right. It's good to check the shape. The shape just tells you that shape is a Python code that tells you the dimensions of an array, right? And in this case, our pictures are a 32 by 32 by 3 array, right? And it shows you 50,000 images, 32 width, 32 length by 3 colors, right? Very cool. All right, very cool. We saw where, all right, so, all right, good, good, good. All right, this dog, so for example, when we looked at plt.image show, right? It shows the image as a color image. And if we said show image 30,500, we see that this is a dog, right? So that dog, can see the leash. You can see the leash here very, very clearly. You can see the dog is actually on its back. Dog is probably playing dead, right? Dog is a well-trained dog. It's rolling over. No, it's not playing dead. It's rolling over, right? Everybody see that, right? If we look at image 55,000, let's see what image 55,000 is. We're going to do a little trick here. We're going to say image equals 55,000, right? Image number, right? equal to, that becomes equal to 5499. That's all. So what you're doing here is you're making it similar to what you did with the features of the house. Remember what the features of the house? You had X1, X2, X3, X4, X5. X1 being the number of bedrooms, X2 the square footage, X3 being the whether it has a pool or not, X4 being the distance from schools, etc., etc. Except that here we have X1 to well, okay, we're gonna say that in a second. Let's look at these shapes. We have many X's. All right. Then we add a dense. The dense is just the neurons in the neural network, right? The dense layer is just neurons. And the neurons now are going to learn the features of the image, right? You add another activation. Like we said, it filters the signal. Then you add another dropout layer, right? Then you add another dense layer. And then finally, you have the softmax. Now, this softmax produces the actual classes. This softmax will produce a vector of 10 digits, right? Will produce a vector of 10 digits, right? Now, here we have the model summary. And you can see that the output shape is going to give you the output shape. So it takes the 32 by 32. Now remember, with the convolution, it produces a smaller array, right? So you took this kernel 3 by 3 and you produced a smaller array, right? Because remember, you multiply the 3 here by this 3 and you produce a single number. Multiply this 3 by this 3, you produce a single number. And then on top of that, you jumped 2 spaces. So then you multiplied it by this 3 by 3. Yeah? So in this case, you would have produced 2 numbers from the 5. Right? You would have produced 2 numbers from the 5. So you have a shrinkage of the array. Sri Lanka, you're not too sure. Sri Lanka looks like she's not too sure. Without the padding, Sri Lanka, it would look something like this. As we said, you multiply these 3 by these 3, yeah? And you produce a single number, N1, right? Then, because we have a stride of 2, say the stride of 2, stride of 2, 2, yeah? It's going to move it over by 2, and it's going to produce number 3, yeah? So it goes from 5 down to 2. See that? Remember what we said, you're multiplying these 3 numbers, right? By these 3 numbers to produce a single number. These 3 numbers is this times this, plus 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 this times this, right? Plus this times this, yeah? So these 3 numbers boil down to a single number, yeah? Right? So N1 is from multiplying this by this, yeah? Don't get it? Still don't get it? All right. Remember we said this is equal to that times that plus that times that, right? Times that plus that times that, right? But you're doing it for all three cells. You're doing it for all three cells, and you're producing one single number. And then you take this and you shift it over. The second time it becomes, you're multiplying it by these 9 cells. Yeah? I'm multiplying by, in other words, these 9 cells produce one single number. You see that? Yes, no? You see it? All right. All right. Let's do something. Let's say, all right, we're gonna do a dirty trick here. We're gonna multiply this 5 by 5 image by this 3 by 3 kernel, right? Now, here's what's gonna happen in each case. So we're gonna take, let's insert a shape. Let's insert a shape. Can you insert shapes here? Can the shapes? Uh-oh. Oh. Oh yeah, we can insert shapes. Yeah. So let's say it's this, right? So the first time we cover these 9 cells, yeah, with these 3 cells, right? You're going to multiply it. It's going to produce 1 times 1, 1 times 1, 1 times 1. That gives you 3, yeah? All the zeros times the ones give you 0. All the negative ones times the negative ones give you -3, right? So you're going to produce 0, right? Then you take it and you cover, you move it 1, 2, yeah? You move it 1, 2, and you're going to produce another 0 here. Then you're going to take this, you go back to the start, you move it down 1, 2, right? And by multiplying it, you're going to produce another 0. And you move it 1, right? 2. Move it 1, 2. Yeah? And you're going to produce another 0, right? The idea here is 1, this is equal to, each of these zeros is 1 times 1 plus 1 times 1 plus 1 times 1 plus 0 times 1 plus 0 times 1 plus 0 times 1 plus -1 times 1 plus -1 times 1 plus -1 times 1, right? 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 That's what this multiplication gives us, right? This multiplication gives us this, right? Now, understand something. So for example, let's actually make this orange. Let's make this green, right? So what we have here is the oranges, right? Then we have the greens. Then we have the yellows, right? Then we have the greens. That's that part of the multiplication. right? And this part is the green part. Right? See what I mean? So you have these ones times these ones, right? Right? So these ones times these ones. You have these zeros times these ones. And then you have these negative ones times these ones, right? 1 times 1 plus 1 times 1 plus 1 times 1, that's going to give you 3 equal to 3 plus 0 plus minus 3, right? And again, it's the same thing, right? This is from the oranges. This is from the yellows. And this is from the greens, yeah? Does that make sense? Kind of. All right, we'll go over it some more. But the idea here is that the multiplication of these 9 numbers times these 9 numbers gives us this single number. Yeah? Gives us this single number. Then we take this, right? And we take this and we move it over 2. Because the stride, we have a stride of 2, 2. Yeah? Stride is 2 across and 2 down, right? And basically we take the stride, move it across, and we produce this next 0. Yeah? Then we go back to the start, move it down 1, 2, multiplying these 9 times these 9, yeah? And we produce this 0. And then we move it across 2 again, and we produce this next 0. So the bottom line is that the output, it starts as 32 by 32. It shrinks it to 16 by 16, yeah? But remember, we have 32 filters. So like we said, for example, you might have a blue filter, green filter, yellow filter, indigo filter, etc., 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 right? So you can detect blue edges, yellow edges, white edges, black edges, etc., etc., right? And so it's actually more than this. It's not just color filters, it's also the actual shapes, right? It's actually the actual shapes as well, right? Horizontal edges, vertical edges, etc., right? Anyway, the bottom line is that we output 16 by 16, so we shrink to 16 by 16, but we have 32 filters. That gives us 2,432 parameters. The activations, same, right? It shrinks it again from 16 by 16 to 6 by 6. Yeah, 6 by 6. When you convolute it again, you still have the 32 filters, right? All right. Now, the max pooling shrinks it even more, right? Remember, with max pooling, all you're going to do is you're going to look at the maximum number in each area. So with a 2 by 2, you take the 5, 1, 2, and 3, you take 5, 1, 3, 0, 4, you take 4, 2, 3, 5, 9, you take 9, 3, 4, 9, 0, you take the 9 again, right? All right. All right. All right. Then you do a dropout, right? Reduces the parameters even more, flatten it, and you get a single vector of 288. Yeah? So this becomes your X values. Yeah? You have 288 features to learn from. 288 features. You put in your dense layer, 512 neurons. The activations from the dense layer is going to be the same, 512. And you drop out, produce 512, and then you have your dense. which gives you the 10 the dense and the activation, which gives you the 10 categories. Yeah, that's the output of it. All right, cool. Now, like we said, you can't process all the images at the same time because you don't have enough memory in the GPU. So you normally take the images in batches. Now, two things happen with batches. So the bigger the memory that you have available is the bigger the batches you can learn from. The bigger the batches is the more parallelization you have. Is the more you can learn in parallel, right? It's like I'm learning from 32 images all at once, but you're limited by memory. The limit here is memory of the GPU or the CPU, but most likely the GPU, right? And then we're going to cover the rest of this next week, right? All right, very cool. Did anybody not get attendance? Did we do attendance here? Okay, let's do some
Hello,
attendance.
Professor. Can you check mine?
Ooh, who's that?
Chandana
Chandana?
Nagili.
Yeah, yeah, Chandana.
Okay,
I'm gonna come down shortly.
thank
All
you.
right, very cool. So, all right, so people, at this point, you can start playing with these neural networks, is the point. Yeah. I've uploaded the code. If you go in the modules, you will see the code, right? That we went through today. You'll see Monday's lesson, and I'm also going to post today's video, right? And then this is a walkthrough from IBM. This code is from IBM on Coursera, right? So you can watch the videos from IBM, and it also talks about the code that we've been through today, right? Next week we finish going through the code, but at this point you can start playing with the code. You can start adapting your data set to this code and start trying to generate some results, right? All right. Let's look at some attendance. Who is here today? Who is here today? All right. So we have, tell us again. Shashank. We have Carlo. We have Darius. We have Shashank. You don't want me to mark Shashank? Why are you saying no is Prashant? Shashank or Prashant? Shashank too. Shashank, what's your last name? Oh, it's here you are. Prashant. Prashant, where are you? Lavanya. Neelam. Who else is here? Rohit. Did we take attendance at all? Yeah, we did. Yeah. Who else? Rohita? Rohit. 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 Oh, Rohit. Okay, who else is here? Soumya, I got you, Soumya. Who else? I did. You don't believe me? Oh, I didn't. I thought I did. Saw you walking, I thought I marked you. Shafi. Shafi. Who else? Yeah, man. All right. See you. Enjoy. Have a good weekend. And watch some Pete and Bass. And tell us all about it Monday. Who else is here today? Nishant. Who else is here? Arif?
Cypress, you forgot Cypress.
I forgot Chief Sai Prasad. Sai Prasad.
Yeah, this one.
All right, very cool. Yamini. Vivek.
I'm in